Welcome to today's Software AG webcast titled Adabas and Natural zIIP, Offloading Mainframe CPU to IBM zIIP Engines. Today's webcast will be presented by Patrick Gould, Chief Architect, Adabas and Natural, Becky Albin, Chief Architect, Adabas and Natural, both of Software AG, and Brian Johnson, Senior IT Specialist, Design and Engineering at Eaton Corporation. As we move through today's presentation, I invite and encourage you to submit any questions that you may have via the Q&A box, which is located in the top right corner of your webcast dashboard. We will address your questions at the end of today's program. In the event that we're not able to answer your question, your submission will be noted and today's presenters will be back in touch with you as soon as possible. Additionally, today's presentation is being recorded. This program recording will be made available to you in an email that will be sent to you later this evening. It will also be posted to the Adabas and Natural playlist on the Software AG YouTube channel later today. Before I turn today's presentation over to Patrick, I would like to briefly introduce you to Software AG. Software AG helps companies with their digital transformation. With Software AG's digital business platform, companies can better interact with their customers and bring them on new digital journeys, promote unique value propositions, and create new business opportunities. In the Internet of Things market, Software AG enables enterprises to integrate, connect, and manage IoT components, as well as analyze data and predict future events based on artificial intelligence. The digital business platform is built on decades of uncompromising software development, IT experience, and technological leadership. Software AG has more than 4,500 employees, is active in 70 countries, and had revenues of €879 million in 2017. It is now my pleasure to welcome Patrick Gould.
Welcome, everybody, and thank you for joining us to our last WebEx of the year. Today, myself and Becky, as you notice on the slide, Becky's name is first, mine is second. That's a pure age thing. We are to present you probably with about 10 minutes worth of recap of zIIP, and then we have Brian Johnson from the Eaton Corporation to give us his story and findings with zIIP. Just a small story there. This weekend it was pretty exciting. I decided to go back to my handyman work, and I replaced all the plugs and switches in my kitchen. So I went to Lowe's to do that. So there I am supporting a Lowe's customer who is a customer of ours, and then of course I bought all the Eaton products. So felt pretty chuffed as I walked out the door with the two customers' stuff in my bag. So a little bit of information, fun stuff you have when you know all your customers. Really cool. So let's get on with the presentation. As we all know, the zIIP portion of Software AG for us is part of the 2050 project, which goes into three main topics: the mainframe offloading, which we're going to talk today, and then of course we've done rehosting, and then of course moving to the cloud. So we're going to focus on zIIP today. I think we've had some presentations on those already, or if not, they will be here next year. So with mainframe zIIP offloading, we're talking about quick wins in excess of 90% offloading in certain cases, and there are no code changes to get it up and running. So this is a high level. This is what our goal is. We're trying to save you CPU seconds. Whether those CPU seconds are important to you at the 4-hour rolling average, or if those CPU seconds are important to you at the total CPU seconds for the month, if you're trying to stay within an LPAR agreement, all of those will become beneficial when zIIP is in place. So this graph is just showing you the different components: Adabas with zIIP, Natural with zIIP, Natural without zIIP, and then you can basically see the red arrow, the red line through in the middle is trying to show you what we can try and get for you. So each customer is a little different, but this is a good indication of what we can do. So again, you're trying to save mainframe costs, of course. You want to ensure continuous operation, and we want to make the mainframe meet all your SLA requirements. So I'll just build this slide out quickly. So zIIP's been around for a long, long time. First came out as a ZAP engine to help with Java on the mainframe. But zIIPs have been here for a real long time already. So they're IBM System C integrated processor. They've been available since the Z9. The main reason for getting them is to try and take some of the load off the GPP and put it onto the zIIP engine. And the reason for that is ZIIPs are not considered in calculating, so in the end you're going to save some money. ZIIPs always run at a maximum speed. They're not throttled, while GPP processor might be capped. So if we look at software AG, ZIIP-enabled options, you can see we started back in 2012 with Natural Batch. 2017, we start Natural Online and Complete. In 2018, we brought in Adabas. And then just recently now, a new one for us is the Natural Online IMS. So we basically have ZIIP products that enable all of our pertinent add-ons at this stage. So say big, no risk, immediate cost savings, etc., better performance. That's what we're trying to give to you. Quick win, quick installation, immediate savings. So you'll get a copy of these slides. You're trying to reduce your IBM workload licensing bill. And then your CEC end of life, you're trying to make sure that when your mainframe comes to end of life, you have other options to move to. Or if you're resizing mainframe, etc., there are options there for you. So offload workload, Natural Complete, Natural Kicks, IMS, Natural Batch, Natural RPC Server, Natural Roll Server, all new enhancements. We've got a lot of enhancements that came in 8.2.7 and a lot of new enhancements that came in version 9. A lot of them around more DB2, being more efficient with the DB2 offload with the new technology we're using there. So we move them back online offload from GPPs to the IBM zIIP processors. That's the main aim. No chips, no changes to the natural applications. Offload workload, free up the workload, put more space on that machine. More stuff can happen on the GPP when we can move stuff to the zIIP engines. And we say a prerequisite for now, seeing as we're so far down the 8.2.7 is really the prereq. We can go a little bit back if we need to, but we would prefer it to be that to be the prereq. A couple of customers. State of California has been around for a long time with zIIP. CalSTRS started. There's a case study out on there, but they basically saved and got an ROI in a very short period of time. The next group at State of California was Board of Equalization, and then lastly, California DMV are now also using zIIP. So great story there for us from California. In the state of Minnesota, they started with the Maxis portion of child support and then later on moved to Prism, and they were saving well over $150,000 a month. So no small money savings there. This is just some reports that you would see at the end of running zIIP, where you can see how much of portion of the CPU ran on the zIIP engine. I'm not going into too much detail of that because they're different customers, but you will have these. But the idea is just to show you how much we offloaded. Here in the USA, we use SMF data as a starting point for any zIIP analysis and POCs. You basically select the type 30s and 70s. If you own MXG software, Brian sends you the software and the query. You run the query, you send it to us, and we analyze the results and present those back to you. And we're always checking data on both, whether it's CPU seconds or rolling 4-hour average, or depending on what would make sense as an ROI for you. So we have probably, I don't know, 50 or so zIIP SMF data analysis, and we just go back to it all the time because everywhere along the line it makes sense to go back and have a look at zIIP for those customers who haven't started using it yet. So I believe that's the end of mine, and I am now going to hand over to my boss, Becky, to carry on with the Adabas piece. Thank you.
Thanks, Patrick. And yes, I am 25 days older than Patrick, and he never lets me forget it. So some of the things Patrick talked about very quickly, I just want to let you guys know that Brian will actually be covering a lot of that from an actual implementation standpoint because they did the trial, they tested it, all that kind of stuff. So Patrick and I are doing very, very high level. We're going to let Brian tell you how it really works in the real world. So Adabase for zip is newer than natural zip. Adabase just came out, the first release in like March, April this year, and then we had another release in October. So in the March-April timeframe, it was Adabase 8.3, and in October it was Adabase 8.4. So now everything's covered. And in addition to that, not only just base Adabase, but as you can see here on this slide, a lot of the add-on products are also being offloaded to zip. And remember, offloading to zip means anything that's not an I/O-based event. And so for Adabase, most of the I/O-based events are disk I/Os, right? In Natural, it could be a screen write, it could be a work file. It's those types of things that will cause us not to offload to zip. But that's a whole different and more in-depth topic. But the big thing for Adabase is it's just like Natural. It's fairly easy to put in. It's basically an 8.3.4 or an 8.4.2. And we've applied, we'll give you a new load library for 8.3.4, but it's basically an 8.3.4 that you're already using or an 8.4 that you're already using, but with ZAPs applied. There's no changes in the Adabase world. Like Patrick said, there's no changes to the natural code. In the Adabase world, you're not changing anything on the data, the associator, the work, P-logs, none of that stuff. It's basically just making sure that you have the software from us and a license key. And you're pretty much good to go. With Adabase, there is some enhancements to the SVC, so we'd have you install a new SVC. But it really doesn't even matter if those applications that are talking to Adabase are Natural, COBOL, PL1, Fortran, SQL, whatever it is out there talking to Adabase. They're all capable of being offloaded, as are a lot of the Adabase utilities as well. So this is a nice little diagram that kind of got this little picture on the side, which no, I did not do. I'm not that good with PowerPoint. Somebody in headquarters did it. But the thing with Adabase is as we start, we're basically running on the zip at all times, and then we just switch back to the general purpose processor as needed. And so it's not a lot. And you'll see from Brian's results or from other results that I'm going to show you is that we get some really high offload percentages. Like I said, it's very, very easy to install. We're going to send you a load library that's compatible to your 8.3.4, which is basically 8.3.4 with ZAPs applied. We call it the AZP library, which is 8.3.5, but it's really 8.3.4 with ZAPs. You're going to install a new SVC, put in the license key, and Brian may mention this, but there's two license keys if you're running Adabase and Adabase zip. There's a key for Adabase and there's a key for zip, and JCL, there's an example of that on how to install that. And there is a new ADA run parameter. And between the license key and the ADA run parameter, that's really also the DBA has to really worry about is putting in the ADA run parameter zip. And another thing to remember, I don't think we actually put it in any of the slide decks, but if the zip processor, like let's say you only have a zip processor, and you could have one or more depending upon how big your mainframe is and all that kind of things, that zip processor can be 100% active, but that will not slow Adabase down. If Adabase can't operate on the zip because the zip is just busy, we'll always go back to the general purpose processor. So don't worry about it slowing Adabase down. If anything, you're going to see much better performance results. And here's just a few examples, like 99% offload, 92% offload, 83% from a bank, telecom in Brazil, all that. And the customers in the US that are doing Adabase zip are seeing similar offload reductions. So just when you're thinking about Adabase zip, the big thing is that IOs are what it's going to decrease your offload capabilities. So we want to make sure that our buffer pool is as big as possible. And also, we might want to think about using Adabase caching because remember, cache is basically an overflow for the buffer pool. So if it's not in the buffer pool, it may be in cache, avoiding the I/O, so improving the offload that we can do. So the buffer pool and the caching all go hand in hand together with zip, and I can work with you guys on that if you're, if you want to do a trial of Adabase zip. Third-party tools plugged in as user exits. not that you don't want to continue to use trim or some other things that use user exits, but be aware that those exits, because that's not software AG code. IBM only allows software AG to offload to the zip processors our software AG code. We cannot offload trim exits and things like that. We are working with IBM and with Treehouse on hopefully coming up with some solutions for this so that all of that will be offloaded as part. But I don't have all the specifics ironed out yet. But if you are using trim, if you're doing certain exits, you will see a slight decrease in the offload of Adabase to the zip engines. And always, as always, you hear it from Patrick and I all the time, apply as many of the fixes as you can, because those fixes are created for a reason, and in particular, if they're zip related, it means that we're offloading even more to the zip engine if there's ZAPs that you don't have applied that you should. So, you know, just to summarize before I pass it over to Brian from Eaton Corporation is that for you guys to use zip, what we would like you to do is what Patrick talked about earlier, send us some SMF data for analysis. We'll take the SMF data, we can get really darn close to how much we think you will offload for both natural and Adabase. And then if the savings looks like it would be significant, let's prove it. Let's give you the software and let you trial it, and you can put it in tests for a couple of weeks, and then you can move it into production. And I think Brian will talk about that. They did that. They ran in test for a couple of weeks or some period of time, and then they moved it into production to prove that what we saw in test is what they're going to see in production. And in many cases, production offload is actually better than test, because the busier Adabase gets, the more it can offload. So production is a way to prove everything. And then there's always going to be some savings here. You know, you're going to be saving significant CPU charges back to IBM and possibly other vendors. So, you know, we're going to have to help you calculate, you know, the return on investment. So with that, I'd like to turn this over to Brian. I've known Brian for a long time. We both actually, prior to here, worked for a common federal government agency. And I've known Brian for a long time. He's helped us out with various things over the years. So Brian, I'm going to turn it over to you to finish out the webinar.
All right. Thank you, Becky. So this is Brian Johnson. Some of you may know me from my involvement in the user community and the user group program for the last 20 or so years. I've worked for Eaton for 25 years, and you see my job title there is just a fancy way of saying I'm a DBA, which I've been doing for the last 21 years, and I'm joining you from Perth, Ontario, Canada today. So I'll go ahead and move on. So I'm going to tell a little background story here, and this starts in early 2017, and really life was getting pretty miserable for us. Our mainframe CPU was recurrently running at maximum capacity, or very close to it, which ended up resulting in some latency, and that caused our input queues to back up. And it's a critical problem because our order management system, which we run on our mainframe, and we call our system Vista, so that's why you see Vista mainframe there. You know, it's a very critical system that runs on our mainframe. And we also run another sister system called Global Vista that also supports Canada, Mexico, and the UK, and a number of other business processes. So really, we have a lot of mission critical stuff on the mainframe that was starting to feel the stress of our demand for CPU capacity. So when our mainframe was slammed, especially during our month-end, quarter-end, and year-end processing cycles, orders took a long time to process, and that would leave our employees and our customers waiting for orders to be fulfilled and shipped. And so it's clear something needed to be done. And on top of that, you know, Eaton occasionally does an acquisition or a merger of some kind. And we happen to have another mainframe in our shop suddenly through our acquisition of Cooper. And we were asked, would it be possible to put the Cooper workload on our existing mainframe box and consolidate that? And that was something we clearly had to say, no, we just don't have the extra capacity at this time. But, you know, if this is something we need to consider, perhaps there's something we need to do to increase our capacity to be able to absorb that. Additionally, we're constantly being asked by the business to do more to support them. And of course, such requests are typically made with the goal of realizing an increase in revenue. So being unable to do more without impacting revenue streams with our existing processes leaves IT in a very untenable situation. And then on top of this, the economic conditions have been improving globally. So even without taking on extra new processes, the organic transactional growth that we were experiencing and we're likely to see going forward was a reality we had to deal with. So our situation was bound to become more dire, even if we said no to everything else, and it was already bad. So when you look at addressing CPU capacity issues, there are some typical or traditional ways in which you would go about adding capacity. So one of the first methods we considered was to add general purpose processors to our existing hardware. Being 2017, we're really under a tight crunch if we were to pursue that option, as the BC12 was going off marketing by IBM at the end of the year. And after that time, we would not be able to make any configuration changes to our hardware. Even if, you know, all that is built into the hardware, you couldn't apply any software changes to turn them on after that point. So we had limited time to consider making changes. The only other traditional method of increasing capacity is really to purchase a newer model that provides more CPU throughput. The problem with either of those methods is they increase your MSU rating, which in turn has an impact on all mainframe software license and maintenance charges, regardless of which vendors you use the software from. And it is definitely very expensive to do either one. However, I had become aware of the zIIP enabler for Natural offering from Software AG through a Software AG hosted webinar much like this one. And I suggested IT leadership that we should investigate this as an alternative to the expensive and traditional methods of addressing CPU capacity. After much discussion, we decided to engage Software AG to learn more about it. Software AG informed us they have the capability of analyzing SMF type 30 and 70 records, as you already heard, to estimate the amount of zIIP offloading we would observe. And this can be done without actually installing anything or even owning a zIIP engine. So we provided a little more than a month's worth of SMF data, and they turn around some very useful reports and charts. And you've already seen like one example of one of the reports, and there are many ways that they represent the data. So I'm sharing a couple of the graphs, which I think speak well to it. You know, picture's worth 1,000 words. So one of the things they show us is what our current state is, what is currently being used, and you can see the top line is our total MSU usage on the mainframe. How much is natural batch and how much was natural CICS. And this is, of course, at the time that only the natural for zIIP was offered, so that's what, you know, they were looking at. And you can see, you know, kind of coinciding with the spikes in total MSU usage, there are similar spikes with our natural batch. You know, we have a very heavy use of batch natural, not only through our production job schedule, but also through event-based processes that control the flow of order papers and other components of order fulfillment. The natural CICS usage, you can see registering there, but it's actually, you know, much less. Now, Software AG estimates that you know, you would see about 80% saving offloading of batch processes to the zIIP engines, and about 60% offloading from natural CICS. And you see, even though, the total MSU usage still has its spikes, the chart doesn't go as high, doesn't reach our capacity levels. And you see natural batch and natural CICS way down at the bottom. The CICS line hardly even registers. So in looking at the information provided to us through this analysis, we believe that the zIIP enablers showed great promise to greatly reduce the CPU demand from batch natural. And as I could tell by the chart, our natural CICS CPU use wasn't as significant. We did see from the results of the analysis that Adabas CPU use was a significant concern. And we're starting to hear that Software AG was in development at that time of the Adabas zIIP enabler. So that was something we wanted to keep in the back of our mind when considering this solution. We did also see from the analysis that we have a number of third-party products, a couple of them that are quite significant, where CPU usage by them is a significant problem because they weren't zIIP eligible. But at that time, we were interested in following up and conducting a trial. So we began the trial engagement. We purchased a single zIIP engine just before IBM pulled the BC12 off marketing, and then proceeded to conduct a trial of the natural zIIP enabler. Installing the natural batch enabler was very easy. As already has been said, all that was really required was an authorized service manager in order to manage the switches between TCB and SRB mode, a license key for the product in addition to Natural's key, and some tuning adjustments designed to minimize reasons for switching into TCB mode, such as to make use of print and work file caching in order to minimize IOs. Unfortunately, our level of the natural CICS interface was below the minimum level required to make use of that enabler, but our findings from the trial were amazing. We easily exceeded Software AG's estimate and realized at least 90% average offloading. This further piqued our interest in what the Adabas zIIP enabler could do for us, as the release date was not very far off at that time. And we turned our attention to this and engaged in a beta test of the product before the general availability release. So I installed that into our sandbox environment, the Adabas zIIP enabler, which was also very easy as it was distributed just like the core Adabas product is. I can't tell you how many times I've installed Adabas. The only difference is that the data sets are coded AZP, or for any Canadians on the call, AZP, instead of ADA. Through testing the product, I did various tests, subtle tests and then more significant load on our sandbox environment. And just as Becky said, the busier Adabas gets, the more offloading you get from it. So we really couldn't wait to see what it could do in our actual production environment. Shortly after the release of the Adabas zIIP enabler, we requested a trial of that version so we could see how well it performed under production load. We also wanted to see how it worked in conjunction with having the natural zIIP enabler installed for our batch environment. So we conducted one final trial of the two products concurrently and scheduled it so it covered the whole month of June 2018, which is one of our busiest months for processing and included our second quarter end processing period. So I'm now going to go through the findings from that trial. So here I've charted our daily MSU usage, including the weeks before and after zIIP enablement. So as you can see from the dates down at the bottom, from May 27th through July 8th was the period that we had the products installed and in effect. And our CPU utilization dramatically decreased over that period that they would have actually peaked through. So I've added a trend line here for effect so you can see, and it resembles a smile that these products put on our faces. So here I'm showing some output that you can optionally report at the end of your batch natural steps. and that's an optional setting, but it's useful for ensuring that your parameters are tuned most optimally as well to know the offloaded savings that you realize. I picked a job at random, not totally at random, but one I knew that performed a significant amount of work to show here. And the offload percentage is quite amazing. You see, this particular job step offloaded 98.61% to the zIIP engine. For the extremely small number of times that the nucleus switched into TCB mode in this job step, it was almost exclusively for I/O operations, which were reduced because we also have current work file caching in effect to minimize, the number of switches needed to do the same amount of I/O. On the Adabas side, my suspicions on the increased offloadability under heavy production load was correct. zIIP statistics are available in several places, including in AOS, which I'm showing here, where you can see we show well over 95% offloaded work on our main production database, which is a consistency week after week. So after the trial, I made note here of some of our observations, and definitely the estimates that Software AG provided were on the conservative side. Instead of just 80% offloading for natural batch, we exceeded 90%, and that's been very consistent. We've also noticed that our batch natural job schedule window runs in a shorter period of time. We get more throughput. It reduces contention, too, between various natural jobs that are running concurrently. We no longer see any latent demand building up on our system. We no longer see any depth in our input queue for pending jobs. And from what we've been able to observe during our trial period, our true CPU reduction, I say when you compare apples to apples, so the same amount of work being done, is about 50%. That's how much we reduced our CPU during the trial. And just to note, really to see that kind of throughput, we'd never seen that even back when our BC12 was brand new back in 2015. So it was clear that the option of using zIIP enablers is going to provide the least expensive way to effectively double our CPU capacity. We also noticed an immediate reduction in our charges for the month of June for the software that is billed based on the peak 4-hour rolling average without spending a dime, because as a trial, it was free money. So because we are still to this date amortizing our BC12 purchase, we saw this as a way to protect our investment in this model and even extend its useful life beyond the end of the amortization period. But because we could show we'll still be able to accommodate business requests for additional functionality and not risk the services we already provide, the decision to purchase the zIIP enablers made the most financial sense because of the ROI that meeting these objectives would provide from the new requests, as well as the reduction in software charges I mentioned. The one thing we do differently at Eaton than a lot of mainframe shops is that we do not bill departments for CPU utilization by way of chargebacks. I believe it would have been easier to demonstrate the savings the software provides and to obtain departmental funding for its purchase by showing how much we were going to save them. But that said, even without following this practice, we were able to demonstrate that ROI would be achievable in a short amount of time and realized. So after that, we purchased the zIIP enablers and made the permanent installation. Just like during the trial, how that demonstrated how the zIIP enablers performed, we've permanently now benefited following the installation of the enablers at the end of October by completely eliminating, hitting our soft cap limits. We no longer have that kind of peak use. We no longer have the latent demand. We have a permanent shortening of our production batch jobs schedule. We see a reduction actually in job contention related incidents, problems that only arise because jobs are going after the same data at the same time. We have the extra capacity now to be able to accommodate the business by providing additional business value. We also have additional value to IT that we've provided because we now have the spare capacity to create a test LPAR to carve that out of our box in order to accommodate performing a ZOS upgrade. And we've also since then turned on additional data archive processes that prior to having the zIIP enablers implemented, we couldn't accommodate the additional work done by data archival. So of important, I guess one final key benefit that we've seen is that, this would be important to those who are responsible for maintaining such systems as we have. We've had no issues at all with the zIIP enablers. So one final slide I want to show, this is our CPU usage throughout the year, demonstrated in terms of percentage. And as you see, the month of June and the month of November, 2 full months where we had the zIIP enablers installed, it dips down from where we were recording and trending. So with that, I've concluded my part of the presentation, and so I'll turn it back over to you, Will, for the Q&A portion.
Okay, Brian, thanks so much. This is a great opportunity for everybody who has not yet submitted their questions to please do so. We do have some questions that we're going to kick off with, so please take the opportunity with the Q&A box in the top right to submit your questions. I'm just going to pose these to all of you, and you can decide who will answer them. So the first question I have is broker offloaded to zIIP?
Patrick, do you want to handle that? Patrick?
At this stage, no, it's not offloaded to zIIP.
But it is coming.
It is coming.
I would like to kind of partially answer that too. For those who have NTireX, the natural RPC servers are offloaded to zIIP.
Yes.
Because that basically runs as batch natural. So we definitely see savings from the natural RPC server side.
Yep, excellent point, Brian. Absolutely. And a lot of our zIIP customers who are also heavy broker users have seen that as well. Absolutely.
There was a follow-on to that, which is as follows. In considering the purchase of ZIIPs, what are your thoughts on having more than one zIIP?
I'll take the first stab. Yeah, I mean, there's no reason not to have as many ZIIPs as you want, but you don't want to also pay more than you have to, right? So the first thing I would do is suggest is we get an idea for how much you currently run on your mainframe, how much we'd offload to zIIP, and that would kind of give us an idea of do you need 1 zIIP or 2 ZIIPs or anything like that. And then as Brian and Patrick and I have said during the thing, part of the stats will show you how much, what percentage of the zIIP is busy and that kind of stuff. So IBM does limit you on the number of ZIIPs you can have. I believe it's 2 ZIIPs for every general purpose processor is the maximum. But a lot will depend upon your workload.
Yeah, and then you also have the normalization factor for zIIP engines. They can run faster than your GPP, so you can have 1 zIIP engine that is can handle twice your consumption of your GPP. So especially when you've got a lot of work that's waiting to run, you can really spread the load out. So check out what your normalization factors are available when you get zIIP engines.
Yeah, to follow up on that, a lot of times when we see your statistics and things, it will show us your normalization factor, and that's printed out in those stats that Brian was showing as well. It'll show us your normalization factor, and generally a zIIP is, like 1.5 to 2 times faster than a general purpose processor. In some cases, it's even more than that. It might be 5 or 6 to 1, depending upon the model of mainframe you have and all that kind of stuff.
Yeah, in our experience at Eaton, we have just one zIIP processor to go along with our 2 general processors, and we aren't anywhere near fully utilizing the zIIP processor. So one was sufficient for us, but we did a study in advance to get a recommendation for our model and use what would be necessary for us, and 1 was sufficient. That's proving to be the case.
Brian, do you happen to know the percentage of that zIIP that is busy on average? Is it like 50, 60% with both batch natural and Adabase zIIP going?
I've seen as high as 50, but
okay.
It typically is much less than that.
Okay, good to know. Good to know.
Okay, the next question I have, what is the duration of an Adabase or natural zIIP trial?
Generally speaking, it's somewhere between a minimum of 30 days and a maximum of 60, somewhere in that time frame usually. Brian, I don't remember exactly how long yours was. Was it a month?
Ours was about 42 days, something like that.
Okay.
A little more than a month.
Because we'll work with you guys. Our team will work with your team and figure out, okay, how long do you think you want to run it in test? How long do you want to run it in production? And as Brian said, when he ran it in production, I like that. It was free money because IBM charged you less for that month, and you were running our software for free, so that was free money for a whole month there, and that was significant savings. So anywhere between 30 and 60 days is usually the average, but probably what Brian's seeing, about 45 days is probably the actual average.
Yeah, and it's normally like Brian did, it includes a month end or something that's significant when you want to, especially if you're running production and you want to see the exact best results, you probably want to run it against the peak month end or something.
Yeah, Brian, I think you said you ran it basically for the entire month of June, right? So you would have called it month end on the beginning of June, I guess, right? Maybe for the end of May?
Yeah, we installed at the end of May, and it expired about a week into July, so we covered that whole month-end processing window.
Okay, great. Well,
the next one, yes, ma'am. The next one I have, does zIIP work mainframe VSE customers?
No, and that's an IBM thing. IBM only makes the zIIP engines available for the ZOS, or as Brian says for the Canadians and others around the world, the ZOS operating system. They are not available for VSE shops.
Okay. The next one I have, how many different Adabase and Natural zIIP products are there?
Patrick, you want to answer the natural part?
Yeah, I think that was on one of the slides. We cover all the online natural, all the CICSs, the IMSs, the natural DB2, natural DSAM, complete. Yeah, anything that's natural, we do.
Okay. And then for Adabase, Adabase zIIP will cover all of the add-on products like caching, Vista, FastPath, the System Coordinator, all of those add-ons. It covers all of them except for, and this is to the best of my knowledge, the event replicator, as we call it, the Raptor server, that nucleus. That one has a separate license key, what we refer to as the ARF or ARK product code. That one has its own separate license key. But Adabase itself includes, like I said, all the other add-on products, Adabase SAF, Vista, FastPath, Delta Save, Review, all of those. Oh, here's an interesting one. We were doing a trial for another customer, not Brian, different customer, and they run Adabase triggers. And guess what? Adabase triggers are actually not Adabase, right? It's a natural batch nucleus subtasking to an Adabase nucleus. So you actually, for that nucleus that's doing the trigger processing, that batch natural nucleus, you'll have to use natural batch zIIP to zIIP enable the triggers, which kind of threw us for a second. We were like, oh yeah, we forgot all about that. So just to kind of keep that in the back of your mind, if you run Adabase triggers or stored procedures, to actually get those offloaded, because Adabase has to execute a trigger, he just fires off a batch natural job that is the trigger code, executes it, and then sends the results back to the application. But the actual execution of that trigger is batch natural, so that has to have batch natural, not Adabase zip. So you always want to go, if you're a natural shop, go natural and Adabase zip whenever possible, because you'll see the results that Brian saw. Okay.
Okie doke. With that, there have been no more questions. So if there is any follow-on questions to today's program, please feel free to reach out to our presenters. But with that, Brian, Becky, and Patrick, thank you very much for a very informative presentation today. Our program has now ended. Enjoy the rest of your day.
Thanks, everybody. Bye.
Thank you. Bye.
Thank you.